Hey guys, welcome back to my YouTube channel. In this video, we are going to solve the linked list cycle 2. In my previous video, we have solved the linked list cycle 1 where we have detect whether there is a cycle present in a linked list or not. If you haven't watched my previous video, do watch it first because it's the similar problem and we will be using the similar approach to solve this problem. So do watch it. If you haven't watched my previous video, you can find the video in my linked list playlist. So without wasting any more time, let's jump to the problem. This problem is saying that you have to return the starting node of the linked list where the cycle is being started. So it basically means you have to return the starting node from where the cycle is being started. So in example 1, you have to return the 2 because it's the starting position from where the cycle is being started. In the previous video, we have checked if there is a cycle present in a linked list or not. But in this problem, you have to return the starting node of the linked list, not the linked list of the cycle from where the cycle is being started. In the example 2, you have to return 1 because it's the first node from where the cycle is being started. In the example 3, there is not any cycle. If there is not any cycle, you just have to return the null pointer. So how we will solve this problem? So it's clear that if there is not cycle, you have to return -1 or null pointer. So first you have to detect the cycle, right? If there is not any cycle present in the linked list, in that case, you just return -1. If there is a cycle present, then you have to find the starting point. So how what do we solve this problem? Let's see. Okay, so what we will do first, we will detect the cycle by using the same approach that we have used in my previous video by using the slow and fast pointers. If we got the if you got the cycle in present in the linked list, then what we will do, we will assign the slow to the head again, and this time we will move slow by one position and fast by one position. Remember, I'm moving slow and fast both by one position, not slow by two position. I'm moving fast by one position. Okay, so I moved my slow by one position, fast by one. Again, fast by one from here to here, fast moves from here to here, and from slow moves from here to here. Again, my slow moves from this node to this node, and my fast move this node to this node. And again, if they are pointing at the same node, means it's the starting point of the cycle. Got it? Okay, so what we did, if we got cycle, means we have used the slow and fast pointer to detect the cycle. Okay, if we got the cycle, then what we did, we assign slow to the head, and again we start traversing, but this time we are moving fast by one and slow by one. If they meet at some node, means it's the starting node of the linked list. Sorry, it's the starting link, starting the it's the starting node of the cycle. So let's let's understand what we did from the start, from the very beginning. We took our slow and fast to the head. Okay, then we will move slow by one. My slow moves to here. Then fast by 2%. Then my fast moves to here. Okay. Again, we did the same thing. My fast moves by 2, slow moves by 1. Again, my slow moves to 1%, and my fast moves to 2% from this node to this node. Again, we did the same. My slow moves to here. My fast moves from this node to this node. Again, my slow moves from here to here, and my fast moves from this node to this node. So they are meeting at some node. Means we got the cycle. If we got the cycle, then what we will do, we'll assign slow to the head. What I will tell the slow to move you went back to the head. So my slow went back to the head, and this time I will tell them slow moves one position, and fast you also have to move one position. So my slow moves from here, and my fast moves here. Then same thing, my fast move by one position and slow moves by one. Then again my fast moves by one position, it reaches here, and slow reaches here. So if they are meeting at the same node again means this is the starting point of the cycle. Got it? So we basically did it in two steps. First, we did the same thing that we have did in my previous video. We detect the cycle. If there's a cycle, then we assign our slow to the head again, and this time we are moving both of the pointers by one step. If they again meet at some node, means it's the starting point or starting node of the cycle. So let's move to the code, and this is where I can show you how this code is working. So what we will do, first we will create two nodes, slow and fast. So my slow will be pointing to the head, and same for my fast. My fast will be pointing to the head. I'm solving in a C++ first, then I will move to the Java solution later. So what we have to do, we have to traverse while my fast not equal to null, and my next of fast, it also should not be equal to null. Okay, should not be equal to null. And what we have to do, I will say slow, can you move to your next? Okay, my slow moves to its next. And what will fast, what about the fast? Fast will move to its next of next. So fast will move to its next of next. Okay, so if there's a cycle, if there's not any cycle, what we have to do, we can simply return the null, because if there's not a cycle, we can't get the starting point of the cycle. So you can simply return the null. If there's a cycle my slow my slow and fast should be pointing to the same node. Okay. So if there's my slow and fast are the same thing, pointing the same node means we got the cycle. If I got the cycle, what we will do, I will tell my slow, can you move to head again? Okay. My slow moves to head. Then what we will do, I will we will again start traversing in a linked list till when my slow should not be equal to fast. If they are meeting at some point means we got our starting node. So in this while loop, what will be our condition? I will say slow, can you move to your next? Slow will be like, of course I can. So my slow will move to is one position, and same for the fast. Fast, can you move to one position? Fast will be like, okay, okay. So what we did, we so if my slow and fast they are meeting at some node again means it's the starting node. So you can simply return slow or fast, is up to you. I'm returning fast, but you can return slow. So let's run it and let's try to check whether it's working or not. Okay. So basically what we did now, first we check if there's a cycle or not. If there's a cycle, then we assign our slow to head again, then start reversing. But in this time, we are moving slow by one and the fast by one. Okay. So if they are meeting at some node again, means it's the starting node. If they are meeting at some node, means it's the starting node. In that case, you can simply return the slow or fast. It's up to you. So it's perfectly running. So let's move to the Java solution. For the Java solution, I will copy the whole thing and I will paste it here. But will it work? No, it will not. Of course, it will not. In the Java, we don't have any pointers, and it's the null, small null. You can, and it's not. This will not be an error operator. So let's do some smart work, and instead of this, let's replace the whole thing with a dot. Okay. So let's replace with the dot. And is there anything we need to change? Yeah, this null. It will be the small null. So let's run it now. I think it should be working. We have changed all the thing. Okay, so it's running. So what we did first, we have checked for the cycle. If there is a cycle, then we assign our slow to head again and start traversing again in the linked list. But this time we are moving slow by 1%. And after that, when they are meeting at the same node again means it's the starting node of the linked list or the cycle. In this case, you can return slow or fast because they are pointing the same node. So I think you got the intuition behind this problem. If you like my video, please like and subscribe. And if you have some comment, do comment below. With this, I'm wrapping my video.